Welcome to Algebra 1, Chapter 9, Section 1, Quadratic Graphs and Their Properties. What is a quadratic function? Well, a quadratic function has the highest degree is 2. Not larger than 2 and not smaller than 2. On the left, you can see some examples. Each of these functions have a degree of 2. On the right, we see some non-examples. This is a parabola. Quadratic functions, when graphed, have the shape of a U or an N, depending if it's opening up or down. Here's our review. Which expression is a quadratic polynomial? Well, the only quadratic polynomial is the one that has a degree of 2. The only polynomial that has a degree of 2 is option D. Our vocabulary is parabola. And let's talk about the true-false for parabola. A linear function has a parabolic graph. That is false. Linear means line. So a linear function has a straight line. Y equals mx plus b. The path of a basketball free throw shot has a parabolic shape. That is true. A parabola that opens upward passes the vertical line test. Yes, it does. So it is a function. A quadratic function is a function in the form y equals ax squared plus bx plus c. That form is known as standard form. Now, in this equation, a cannot equal 0. So you have to have a coefficient for your squared term. That's one of the things that makes it a second degree. The graph of any quadratic function is called a parabola. If your a term is positive, your parabola is going to open upwards. If your a term is negative, it's going to open downwards, like an N. Please be aware of what the vertex is and what the axis of symmetry is. When graphed, quadratic functions will have either a minimum point or a maximum point. When the graph opens upwards, meaning the a is positive, the vertex will be the minimum point. When the graph opens downward, which is when the a is negative, your graph will have a maximum. The minimum or maximum point is known as the vertex. Here's a very quick review. What are the coordinates of the vertex in the graph? Well, here's the vertex, and as you can see, the coordinates are -2, -3. Since the vertex is at the lowest point on the parabola, the vertex is the minimum point of this graph. Here we're going to graph the function y equals -3x squared. Now we know this is a quadratic function because it has a degree of 2. We also know that the graph will be a parabola. But let's go ahead and complete the table of values, and then we'll look at possible graphs. So here I've went ahead and filled out the table, and here are some things. We have a couple of points that are reflections of each other. -2, -12, and +2, -12 are reflections of each other. -1, -3, and 1, -3 are reflections of each other. So let's go forth and see what that looks like as a graph. If we plotted points, we would end up with points here. So this would be the graph of the function. This makes our domain, and this would be our range. By all means, we can graph every quadratic function, but it's a bit easier if we can come up with some general theories. For example, if a is positive, a being the coefficient of the variable squared term, the graph opens upward. If a is negative, the graph opens downward. take a moment, pause this video, and fill out the chart, and then attempt to graph both equations. Restart this video when you're done. As you can see, I filled out the chart for the first x value of -2 and plotted the point. Here's the next one, which is the point -1, 1. Then we have the point 0, 0, the point 1, 1, and the point +2, 4. And I have graphed the blue highlighted equation. Now I'm going to do the green highlighted one. My first point is -2, 1. My second point is -1, -2. My third point is 0, -3. My fourth point is +1, -2. And my last point is +2, +1. Looking at these two graphs, can you explain how you get the graph of y equals x squared minus 3 from the graph of y equals x squared? Yes, you simply lower it 3. Can you come up with a general theory on this? You simply move it up or down based on the C term. Here's your check understanding, and then you will see 2 additional slides at the end that we'll talk about in class tomorrow.